Hello and welcome back to Let's Code Physics. This is the first episode in a new series that is a tribute to our subscribers. This channel has been hovering around 600 subscribers for the last month. I've been very pleased with that. I've been very thankful for all the support that everybody's been showing. If you're not a subscriber yet, you can click on the subscribe button that's below this video. And I wanted to do a tribute to the subscribers for this channel. And one of the viewers suggested exploring the physics of collisions, the physics of things bouncing off of each other. And I thought, wouldn't it be great to make a box to simulate a box of bouncy balls, one for every subscriber. So I made a trial code, put in 600 bouncy balls that were all bouncing around, and let's just say my computer slowed to a crawl. It was not terribly exciting. Then I thought about what if I didn't have 600 bouncy balls? What if I had one bouncy ball for every country that my subscribers are from? Because if you take a look at the subscriber list, we've actually got subscribers from 70 some odd countries. I've got them here sorted by the number of subscribers. So the majority of them are from the US, but we've got a fair number from UK, Germany, Canada, Netherlands, and on down the list. As of today, it's 69 countries, including all the way down to a few countries with a single subscriber. So for those of you in Puerto Rico, Chile, Serbia, Australia, and Czech Republic, congratulations, you are 100% of the subscribers from your country. So what I'd like to do is I'd like to set up the program to where each bouncy ball represents a different country, but the size and mass of the bouncy ball is given by the number of subscribers for that country, in that country. Got to get my prepositions correct. So what I'm going to do is I'm going to download a report of the subscriber numbers, and we're going to save that in here. Yeah, that ought to be fine. And I've gone ahead and made up a spreadsheet to process this information. So what I'm going to do is I'm going to grab the country name, the abbreviation, and this is this column C here is the number of subscribers. The rest is views and watch time and watch minutes, etc. I'll pick through that at another time. So I'm going to grab all of these. Now this has included countries where I have had subscribers and lost some. So for example, it's telling me that I had some in Thailand and then lost them. I had some in Kuwait and then lost them. I've also have -1 subscribers in an unknown country. Not entirely sure what's going on there, but we'll just not include the zeros and -1s there. So I've got a spreadsheet set up here, and so I can just paste in those values. And basically this is automatically creating some code for me using the concatenate command in Excel. I'll let you go look that up because this is a Let's Code Physics, not a Let's Learn about all the textual stuff within Excel. But basically this is going to allow me to create the different masses for the different bouncy balls for each country. So what I'm going to do is I'm going to take this now. Oops, I don't want all of that. I just want down to Hong Kong. There we go. I'm going to copy that and I'm going to paste that into my code. This code is going to be in VPython, since VPython is a lot easier to animate in, and this is obviously a very animation heavy code. The way storing data works in VPython is through these things called lists, which are actually really neat because you can start a list and then add things to it, and you can have different types of things stored in a list. You can store numbers, alphanumeric characters, even vectors within a list, and then have lists of all different types of things. So it's actually pretty powerful. But what this command does, this append command, is it says there's already a list called mass list. So I actually need to start a mass list. Let's just get that equal to 0. And much like C, Python starts counting lists at 0. So what I'm going to work up the code so that it just ignores the 0. And so we're going to have the number of bouncy balls equal to, I think it was a total of 69, it's a total of 68. Because this is the header up here. So we've got a total of 68 bouncy balls. My numlock on? Yes, it is. Okay. So we got a total of 68 bouncy balls. So this is the number of bouncy balls. This is the start of the mass list. So what the goal for today's episode is to set up all of these 68 bouncy balls inside of a box. So I need to actually create the bouncy balls, and I need to set up a frame for the box. We're going to start out the box in just 2 dimensions, so they're going to be bouncing around in a square. But by the end of the series, we're going to upgrade it to a 3-dimensional box, so they'll be bouncing around in 3 dimensions. Okay. So we've got our list set up going all the way from the United States down to Hong Kong. There we go. So we've got 1 bouncy ball for each country that we've got subscribers in. And so what I need to do now is I need to actually create the bouncy balls themselves. So what we're going to do is we're going to set up a loop that'll create each ball one at a time. So we're going to say while iBouncy ball is less than or equal to number of bouncy balls. So I need to start iBouncy ball at 1. Actually, let's do... Yeah, let's do it that way. That's fine. And I need a colon there. Okay, so we've got our while loop started here. So while the counter is less than or equal to the number of bouncy balls, we're going to start a bouncy ball list. So we're going to start a bouncy ball list. And we're going to say of 0 equals 0. Again, that's just to start the bouncy ball list. And so what I need to put in here is I need to add to the list. So I need to say bb_list.append. And what I need to put in here is, what I need to put in parentheses is the thing that I want to add to the list. That's what I've been doing up here is that I've been adding to the list. So this append command just means add the next item to the list. So this is going to be a sphere. It's going to have a, let's see, the first thing we need to set for a sphere is its radius. And now this is where we have to do a little bit of chemistry because I've got the mass set. I want them all to have roughly the same density. So let's see, so density is mass over volume. So volume is density, so density is mass over volume. So volume is mass over density. There we go. So it should be proportional to the mass, but that means the radius needs to be proportional to the mass to the 1/3 power, since we're talking about the radius, and volume goes like radius cubed. So you need to take the cube root of that. There we go. So we got our radius set up, and we've got, we need our position set up. So I need to set up the thing's position to be something in the x and something in the y. So I need some way of getting a random number in the x direction and a random number in the y direction. The way we're going to do that is we're going to use the rand command. So rand just creates a random number between 0 and 1. So the way we're going to do that is we're going to say random here. Now I want this to be anywhere inside of a range from -1 to 1. That'll be the original size of the box. So let's say this is going to be 2 times this minus 1. So the way you work with a random number generator is that this random number generator is going to spit out some random number between 0 and 1. So what I'm doing there is I'm scaling it, saying, okay, now make that between 0 and 2, and then subtract 1 from it. So the net result is it'll be a random number between -1 and 1. So let's see. So we've got, and then you do the same thing with the y. Oops, not sure what I did there. Here we go. Copy and paste. So now I've got an x random value and a y random value so that they're not all in the same spot. Cool. And for right now, let's just make them all white spheres so they're easy to see against the black background. I might, off camera, look up some, like maybe the primary flag color for each country. That would be a little bit longer to set up, but so I'm not gonna bother with that here. Okay, so I've got the sphere, I've got the radius, I've got the position, I've got the color. Cool, so I can close that up there. And so if I run the code now, I should get 68 spheres randomly distributed. So let's see how we did here. Oh, most recent. Name mass_list is not defined. All right. Mass_list of 0. Oh, right. You don't start out with an address. You just start out with the actual list. There we go. And I need to do the same thing here. we go. Let's try that. Name rand is not defined. Okay, I'm going to need to look up what the random number command is. So I'm going to cut here. Okay, so I found a few mistakes while I was cut away. One is I did get the random.uniform fixed. So I got my Scilab and my Python confused because Python actually has a random number generator that will get you a number between a lower bound and an upper bound. And so that's what I've done here from -1 to +1. I've also adjusted the position to actually include a z coordinate. That's kind of important in a 3D environment. And then, of course, I also had to increment IBB or else the loop wouldn't go anywhere. So I did find some mistakes off camera. I've also found one mistake that I thought was pretty funny, so I've left it in for right now. So we're going to run the code, and this is what we get. Is one giant bouncy ball. That is because while I set everybody to be within -1 to +1, the radius of the biggest one is cube root of 214, which is much bigger than 1, so the US is sort of taking over the screen there. That was not intentional, but it's pretty funny. So what I actually need to do is I actually need to start thinking about the length of the box now. So actually, let's call that box length. There we go. Let's set that to be, let's see, our largest one is 214, so let's make this one, let's go with 500 to the 1/3 power. There we go. And now we can change this from -1 to 1 into negative box length to box length. Box length, and I'm just going to copy and paste that so I don't have to embarrass myself trying to spell length. There we go. There we go. Okay, let's see if all of our bouncy balls become visible now. F5. Oops. Oh, that's right. Python does not like carets. It likes double asterisks. There we go. F5. Oh my, that is quite amazing. So that looks more like a molecular something or other. It almost looks like a country, kind of. Okay, so let's keep adjusting this box length until we get these folks better taken care of. In fact, maybe I should divide this thing by something. Let's divide this thing by maybe 100 or something. Oh, there we go. Now those are a little bit small, so maybe 100 was a little much. So let's try dividing by 10 instead. Oh, no, that's interesting. Okay. This is going to be really cool in 3D, by the way. I keep rotating it, but they're all in one plane, so this is going to be really cool in 3D. Okay, so each one of these bouncy balls represents a different country where we have viewers. And so what I'd like to put in now is walls for the bouncy balls to bounce against. So I'm going to go, let's put those walls in up at the top. So actually, let's put this in at the very top. So let's call it left wall equals, and then we'll call them right wall, top wall, and bottom wall. So we're going to call this thing, I believe the command is box. And so what I want to do with this is I want to give it a position that is all the way to the left. So I actually need to define my box length ahead of time. There we go. Paste, there we go. Okay, so we're going to give this thing a position. Let's see, if this is on the left side, I need it to be at negative box underscore length, comma 0, comma 0. And I want it to have a size of, let's see, now in the X direction, I don't want it to be too terribly big. So let's give that a width of, let's say 0.5. And then we'll give it a height of 2 times box underscore length. Oops, box underscore length. And we'll give it a thickness this way. Let's go with 0.5 right now, see what that looks like. And let's make its color, let's go with blue, sure. All right, so that goes to that. Let's see if I get my left wall the way I envisioned it. Okay, so actually that is a little bit thick in the X direction. So I can probably make that a little bit thinner, make that a 0.1. Okay, cool. That looks better. There's a little bit of depth to it in the Z direction. So it's not just, a blue sliver there. Okay, cool. Actually, let's give it a Y position. Excuse me, let's give it a Z position. Let's make it come out just a little bit of... Oh, no, wait, that's the center. That is fine. Never mind. We're good here. Yeah, because if I rotate it... Yeah, okay, yeah. So the plane that the bouncy balls make is centered around the wall there. Okay, so now I can do the same thing. I can make a right wall. The only thing I need to change is change the X position to a positive box length, F5. And there we go. Now I just need to give it a top wall and a bottom wall. Copy, and we're going to go paste. So we're going to go top wall and... Oh, actually, I should just do the top wall because I'm going to be making some changes, and then I'll copy and paste that. So now instead of the X, instead of it being located to the left or right, now I want it located on top or bottom. So let's go with 0, positive box length since it's the top one, and we'll get rid of one of these zeros. And now I just have to switch these two. So I'll cut that and paste it over here. That should get me the top wall. Cool, this is starting to look like a box. Awesome. And now I can do the same thing and make a bottom wall. Let's go bottom wall. Now I just turn this into a negative, and that should give me a complete frame. There we go. So now everybody is inside this frame. So the next thing that we want to do is get these bouncy balls moving. We've got them all sort of randomly distributed now. So what we're going to do in the next episode is we're going to give those bouncy balls each a random velocity, and we're going to set them up to bounce against the walls of the box. And that'll be what we do in the next episode. So thanks so much for watching. See you next time. Bye-bye.